A new study has found honey from stingless bees can help kill off bacteria and fungi that's harmful to human health. The University of Sydney study has been years in the making and researchers are very excited about the possibilities. We're joined by Dr. Fernandes, who is the lead researcher. Doctor, thank you very much for joining us. Now, I just said in our intro that the stingless bee honey can actually kill off bacteria. Were you expecting to find this?
Yeah, so there's been a lot of research around the world looking into honeybee honey, which shows that it's very effective against certain types of bacteria, but really a lot less looking at honey that's made by our native Australian bees. So when we went into this research, we were really hoping that we would be able to find that the honey was effective, but we didn't really know what to expect, whether it would be very similar to honeybee honey or quite different. And what we ended up finding is that it's incredibly potent and that it is quite different from honeybee honey. So regular honey is quite variable and depends a lot on the flowers that the bees are visiting, but we found that this stingless bee honey is very consistently able to kill bacteria and fungi, even if it comes from different locations and different seasons. So that's really promising as a potential medicinal treatment.
So what does this mean? How could this honey help people?
So probably the most realistic use of it would be in creams or gels to treat wounds or sores or those kinds of things, particularly in cases where maybe our traditional antibiotics aren't working because of resistance issues. So this is still early research, but there is really great potential for these honeys to be translated because honeys are edible, they're non-toxic, we already know that they're safe, and certain products are already on the market medicinally, such as Manuka honey. So the pathway to getting it out there would be a lot shorter than it would be for, say, a new antibiotic.
So you just mentioned Manuka honey there. It is well known that that can help fight off colds and flus. It can kind of help with some cuts and grazes. And First Nations bush medicine have been using honey for infection for quite a while now. How is this honey different?
So Manuka honey is quite unique in that it gets its properties from the nectar of certain types of plants. So this is the leptospermum tree or tea tree. The stingless bee honey, on the other hand, is quite different because it seems to have the same properties regardless of what plants the bees were foraging on. So we don't know exactly what causes this unique activity yet, but we think it's likely something to do with how the bees are processing the nectar or something that the bees themselves are adding into the honey. So that's really exciting because it means that this honey is potentially more consistent and able to be sourced from a wider variety of locations and not relying on a certain type of plant species.
During your research, how did you take apart all the parts of the honey to find out what was actually helping, like the microbial assets to it? I know there was like hydrogen peroxide is a very strong quantity within honey.
Yeah, absolutely. So honey is an incredibly complex mixture. It's got about 200 different things in it. So one of our main challenges is figuring out how to break it down and how to figure out what exactly is doing that. You quite rightly mentioned hydrogen peroxide, which is a really major component in a lot of antimicrobial honeys. And we found that the stingless bee honey makes a lot of hydrogen peroxide, a lot more than your traditional honeybee honey. We also looked at a couple of things beyond peroxide, so things like proteins that might come from the bee themselves that they add into the honey, things like phenolic compounds, which are plant-based chemicals that come from the plants that the bees forage on. And we found that there was a lot of unique signatures going on in this honey. As I mentioned, we're still trying to figure out exactly what those are, but so far they're very strong and they're very different from honeybee honey.
So when can we expect to see this type of honey on the pharmacy shelves?
That's a great question. I would love to say very soon, but science can move quite slowly. I'm really hoping in the next couple of years to go further with this work, to identify exactly what those unique compounds are, to test against some antimicrobial resistant microbes, and to even go and do some preclinical and clinical trials to see if we can actually get this out there as a product. So fingers crossed.
Okay, I'll be crossing my fingers too. It sounds great. Dr. Fernandes, thanks for joining us.
Thank you.
Now, some new research has found heading a soccer ball alters the